We have done an IOT project on smart health monitoring system for COVID-19 patients. Now we will see the entire implementation of our project. So these are the hardware components of our IoT health monitoring project. This is the Arduino board where it has the microprocessor which will control the entire thing. It is the power cable for Arduino board. We have some male to male and male to female jumping wires, connecting wires to connect the circuit. This is the LCD display where we will see the output. Then we have the breadboard. Next we have LM35. This is the temperature sensor. Next we have pulse sensor which will sense our pulse. Then we have the resistors, LED, and this is the ESP8266 Wi-Fi module. This Arduino board, it doesn't have Wi-Fi module inbuilt, so we are using this ESP8266 module so that the data of the sensor can be sent to cloud and stored in cloud for further analysis.
You can see all the components are connected successfully, and the values that are heartbeat and all the temperature sensors. Using this method we can collect the values, and it will show to the serial output data. And as you can see, the data is coming in the box itself. It is 93 bpn and temperature is 80.34. So all the things are perfectly working here.
So whatever data we have got from Arduino IDE serial output, that data needs to be sent to a IoT cloud platform. We are using ThinkSpeak over here, and we have used ESP8266 just to transfer the data to cloud. So here is the temperature and here is the pulse rate, which is coming continuously, and it is forming a graph. That is it is changing over the time. The pulse rate and the temperature is changing, and we are getting this data like this in ThinkSpeak. We can upload this data, and we can also download the data, and we can use it for further analysis.
So that's why we are uploading the data that is collected from that particular sensors and through the cloud, and for further analysis. And here, that's why we are apart from that also, we taken a data set from the Kaggle for our future analysis and prediction. We using the logistic regression algorithm, though we have to take all the attributes, but we are taking only 74 attributes because all other attributes are we have selected for the pre-processing part. So the coding section I have to now show the coding section. This is the coding part which we have to implement for the dataset. The dataset is Brazil COVID dataset XLSX. You can see and the pre-processing part also there. Now we are doing the pre-processing part also. Here we are doing the pre-processing part. We are dropping some columns because of the null values, and also for the empty values we have to implement some columns also. Some zero values into that, and then normalize the data using min max scalar algorithms. Min max scalar is a pre-processing algorithm, pre-processing method, and then we have to divide the data set into two parts, 70% for the training data and 30% for the testing data. And using the testing data, we have to predict that it is whether the person is COVID positive or not, and using the training data, we have to train the data set that for the further analysis. So using the sklearn matrix, we are using confusion matrix here. The confusion matrix is still showing us some of the predicting values here, and we have to print the score and also the confusion matrix here. And if we wanna print it at the description, then you can also print the description part also. So where all the things are about for the data set. The data set is given below, that is patient ID, patient age, and if it is COVID positive and not, and all the things, the blood corpuscle, how much amount of blood corpuscles are available, and all the things are there. So that's all about the analytics and the pre-processing part and the algorithm implementation analysis part. Thank you.